All right, so what we're going to start doing now is we're going to start tying everything together that we've been doing. This is called evaluating trig functions of any angle. We're going to spend a couple days on this. So evaluate, that means you're going to give me a number answer. So whenever you see evaluate, that's what we want to think of. So let's start by just kind of quickly going over these steps to success here. What we're going to want to do, first thing you want to do is plot the given ordered pair, and you'll see how, go through all this. Then you're going to draw a line connecting that point to the x-axis and one to the origin. Again, I'll show you what I mean by that. Then what we're going to do is we're going to find the hypotenuse. The hypotenuse is the radius, so it's always going to be positive. So just kind of keep that in mind as we're going through this. And then we're going to evaluate, find the number of the trig functions. So let's go ahead and do this. Let's just say that this was the ordered pair that I plot. Okay, I'm just going to call that xy. So that was our step one. Then we're going to draw a line connecting the point to the x-axis. We're going to go straight down. We're going to make a right angle out of that. And we're going to draw one to the origin. So do you see how we just made a right triangle? You want to make sure that one side of your right triangle is always touching the x-axis. So here's my x-axis. If it's not touching the x-axis, then you drew the triangle wrong. What I mean by that is you don't want to draw the line this way. You do not want a triangle that looks like that. What we're looking for here is that angle. We're going to call it theta. All right, let's try some with actual numbers now. So first thing I'm going to do is I'm going to make a xy axis here, and I'm going to plot the point -4, 3. So I've got, I'm going to go back 4, and I'm going to go up 3. You really don't need these tick marks there. So I plotted that point. That's the point -4, 3. Now I'm going to make this into a triangle. So it's going to touch the x-axis always, and it's going to touch the origin. What we're looking for here is that theta. The little tick marks got in the way, didn't they? All right, I need to label the sides. What we're looking for, not looking for, but what we're looking for is the angle. But we know that this side went back 4, so that's -4. This side I went up 3. So again, if I start at the origin, I went left 4, I went up 3. I don't know what the hypotenuse is. It's typically like the radius of a circle here, but so I'm going to find that. That's going to have to be positive, always. So we're just going to do Pythagorean theorem here. So we've got 3 squared plus -4 squared equals r squared, or c squared, whichever you want to call that. So I've got 9 plus 16. This should be pretty easy here for us, is 25. When we take the square root, it's typically plus or minus, but all I care about is the positive value. So now I've got everything I need to go ahead and evaluate the different trig functions. Remember, evaluate means give me a number answer. So let's remember what sine, cosine, tangent means. We've been doing all this, but like SOHCAHTOA, sine is opposite over hypotenuse. So if I'm looking at the angle here, that's why that's labeled. Sine is opposite over hypotenuse. So it's just 3/5. Cosine is adjacent over hypotenuse. Oops, I meant to put a over h there. Hang on. Cosine is adjacent over hypotenuse. We'll just put a over h here. The adjacent side is -4. The hypotenuse is 5, so that's -4/5. Make that a little darker there. Tangent is opposite over adjacent. TOA. So the opposite side is -3 from this angle, and the adjacent is -4. So it's really -3/4. All right, cosecant is just a reciprocal of sine, so I'm going to flip sine over. So that's 5/3. Secant is a reciprocal of cosine. Now, if you get kind of confused which ones match up with which, I feel like cotangent usually is pretty easy. Usually we have them kind of labeled like this, but not always. Cotangent, tangent, secant starts with an S, ends with a C. Cosine starts with a C, ends with an S. That's how I try to remember that. If you just kind of flip it, they've got different middle letters, but the reciprocal of cosine is negative 5/4, and then the reciprocal of tangent is negative 4/3. And that way you just don't have to memorize. This is typically, this is actually really the hypotenuse over opposite. This is hypotenuse over adjacent, adjacent over opposite. So I think it's easier just to find sine, cosine, tangent, and then flip them all. All right, let's try another one. Step 1, we're going to plot the point 3, negative 3. So I'm going to go over 3 to the right, and then down 3. So I'm going to go over 3. I'm not going to put the tick marks this time. And I'm going to go down 3. So it should be about right there. So we're going to draw a right angle touching the x-axis. Put my right angle over there. And then I'm going to draw another one touching the origin. So again, always double check that your triangle is touching the x-axis. If it's not, then you did mess that up. All right, there's our angle. Let's label the sides that we know. So I started at the origin, I went over 3, so that side's positive 3, and then I went down 3, that's negative 3. So if you have questions where I'm coming up with these, make sure you let one of us know. Then to find this hypotenuse, we're going to do a squared plus b squared equals c squared. Just Pythagorean theorem there. 9 plus 9 is c squared. 18 is c squared. Take the square root. Type that in your calculator. You're going to get 3 radical 2, which, if you guys see here, if those two sides are the same number, I mean, I know that's negative, but maybe you'll realize that that's a 45, 45, 90 triangle, and the hypotenuse is just a leg times radical 2. So we did go over that too. All right, let's go through our sine, cosine, tangent. Sine is opposite over hypotenuse, so the opposite side is negative 3. Hypotenuse is 3 radical 2. Do notice that those 3's cancel out. I can't have a radical at the bottom, so I'm going to multiply the top and the bottom by radical 2. So I can cross these out also. So I've got radical 2 over radical 2 times radical 2 is just 2. All right, let's take a look at cosine. Cosine's adjacent over hypotenuse. If I look at my triangle here, the adjacent side is positive 3. Hypotenuse is 3 radical 2. So I'll do the same thing again that I just did. These 3's do cancel out. So right now what I have is 1 over radical 2. I can't have a radical in the denominator, so I rationalize. I multiply the top and the bottom by radical 2. And that gives me radical 2 over 2. Tangent is opposite, which is negative 3, over adjacent, which is positive 3. Negative 3 divided by 3 is negative 1. Okay, let's come over here and let's flip all these. Now, if I flip this, my answer, I'm going to have 2 over radical 2, which I can't have a radical in the denominator, so I'm going to multiply the top and the bottom by radical 2. So that's going to give me 2 radical 2 over 2. You see that these 2's cancel out, and I'm left with just radical 2. All right, this is the same thing as what we just did, except sine is, I didn't make that negative, did I? Sine is opposite over hypotenuse, so that's a negative. That's a negative radical 2 over 2. So that's a negative radical 2. I'm sorry about that. So sine was opposite, which was negative radical 3 over hypotenuse. So if I go back and I look at cosine, though, I could do all this work again. If you go back to right here, I crossed out those 3's. If I flip that, because right now what that says is that's 1 over radical 2. If I flip that 1 over radical 2, I'm going to get radical 2 over 1, which is just radical 2. All right, tangent. Tangent is opposite over adjacent, so I didn't mess up the negative that time. If I flip that, I've got 3 over negative 3, or if you just flip a negative 1, it's still just going to be a negative 1. So again, I got that from flipping 3 over negative 3, which just became a 1, negative 1. All right, watch your signs. You see how easy that is to mess up. Let's try one more. All right, so this time I've got 2 negatives. So I got to really be careful here. I'm going to have negatives all over the place. We're going to plot that point, -2, -5. So my xy axis, I guess I should be labeling these, I'm not. So if I go back 2 and down 5, it's going to be about right there. Draw a perpendicular line to the x-axis and then connect it also to the origin. Double check that your triangle is touching the x-axis. That's very important there. I'm going to draw in my, technically what that is, that's a reference angle. We did reference angles already. It's the angle that touches the x-axis, and our radius, hypotenuse in this case, is what's going to help us find what we need. All right, so here, what I have is I started at the origin, I went left 2, so this side is -2. And then I went down 5, so that side is -5. We're going to do Pythagorean theorem to find c squared, to find our hypotenuse. Keep in mind it has to be positive when I do this. So I've got -2 squared plus -5 squared is equal to c squared. So I've got 4 plus 25 is c squared. I've got 29 is c squared. And then the square root of 29 does not simplify, so c is radical 29. So my hypotenuse is positive radical 29. Okay, let's start filling all this in here. Sine is opposite over hypotenuse, cosine's adjacent over hypotenuse, tangent's opposite over adjacent, SOHCAHTOA. Okay, always go back to that angle. I purposely did it in a different color so it kind of stuck out. So the sine is the opposite side. Let's put that negative there right away. Over the hypotenuse. All right. I can't leave it like that. I can't have a radical in the denominator, so I'm going to multiply the top and the bottom by radical 29. And I have -5 radical 29 over 29. Can't do anything more with that. Let's look at cosine. Cosine is the adjacent side. There's my adjacent side. It's -2 over the hypotenuse, which is radical 29. Can't have a radical at the bottom in the denominator, so I'm going to multiply the top and the bottom by radical 29. And I've got -2 radical 29 over 29. All right, finally I've got tangent. Tangent is the opposite, which is -5, over the adjacent, which is -2. Negative divided by negative is positive, so I've got +5/2. All right, let's come back up here and find the reciprocals of all these. Cosecant, secant, cotangent. So if I'm going to flip my answer, do you see how I'm going to have a radical in the denominator, and then I'm going to have to rationalize and do some work? If you go back to the original right here, before I rationalize, before I multiply this, and if I flip that, I get radical 29 over -5. That negative should just be out in front. Do you see? Now I don't have to do anything with that. I'm just done. Again, here's what I'm saying. If I would have flipped this, let me do this out to the side. If I would have flipped this and I have 29 over -5 radical 29, it's not wrong. It's just that you have to now go like this. And we're going to have 29 radical 29 over, let's see, that's just a 5 there, -5 times 29, and then those 29s cancel out, and you'll get your -29 square root of 29 over 5. Just more work. Not wrong. I just don't like to do more work. So I'm going to go back to here, and I'm just going to flip this original one. So I've got radical 29 over -2. I'm just going to put that negative out front. Finally, if I flip my tangent here to get cotangent, I've got 2 over 5. All right? A little bit more here. Okay, so now we're going to do something called quadrantal angles. This is an angle, when you put it in standard position, its terminal, its ending side, is actually on either the x or the y-axis. So you're going to see you don't have a triangle this time. So there's really no right triangle when you have one of these quadrantal angles. So when we're doing these, it's always going to be a multiple of either pi over 2 or 90. It's going to be, we're going to look at one of these 4 ordered pairs. 1, 0, 0, 1, -1, 0, 0, -1. So let's remember, we did this with that whole unit circle thing, but sine always goes with the y value. Cosine is always going to go with the x value. And tangent is always sine over cosine, which is just my y over my x. And this is the exact same as opposite over hypotenuse, or opposite over adjacent. So, I said that wrong. Tangent's opposite over adjacent, which is gonna go right back to the y over x. So it's not like we're giving you guys anything new. Sine is the y value. Here's my last one. When we did sine, it was opposite, which that came from the y value. Our hypotenuse is going to be 1 for these. Well, we don't really have, so that's why it's just the y value. Cosine, when you look at it, is adjacent. Adjacent is my x value. Tangent is opposite over adjacent, y over x. So I just wanted to kind of show you guys where that really comes from. It's not like we're changing our minds now. All right, let's try this. So we're going to evaluate the 6 trig functions of theta. This time theta is 180. So we need to figure out where 180 degrees is. So I'm still going to make my triangle. I don't really have an ordered pair to plot. This time we gave you the angle measurement. So it's 180 degrees. So remember, we start here, that's 0 degrees. And then we go up here, and this is 90 degrees. All the way to here, and that's 180 degrees. So my point is actually right there on that axis. So the ordered pair right here goes back 1, so it's -1, 0. I do want to point out too that 180 degrees is also pi. So this problem could have said that theta is pi. These mean the same thing. All right, now let's go ahead and notice we don't have a triangle. Sine goes with the y value. So here's my x value, my y value. Y value is 0, which is 0. Cosine goes with the x value. The x value is -1. And then tangent is y over x, sine over cosine. Y is 0 over x is -1. 0 divided by anything is just 0. All right, now we're going to go and we're going to flip all of these. So if I flip 0, that's really 0 over 1. This becomes 1 over 0. You can't divide by 0, so that's technically undefined. I'll put it all in here for now. If I flip -1 over 1, I'm still going to get -1 over 1. If I flip 0 over -1, I get -1 over 0, which is another undefined. All right, so there we just did our first quadrantal angle. We've got 2 more to go. All right, so the next quadrantal angle is 5 pi over 2, and you probably don't realize it's over or it's quadrantal yet, but usually when we graph it, we'll find it out. 5 pi over 2 is actually not on my unit circle here. So if I were to look at just a full circle, it starts at 0. If I go all the way around, a full circle is 2 pi. If I change that to over 2, that's really 4 pi over 2. So this is actually bigger than a full circle. So what I have to do is I need to take a circle off of that. So this is where I find like a reference angle so I can work with within a full circle. So if I subtract 2 pi, if I subtract 4 pi over 2, what I'm really looking for here is pi over 2. Pi over 2 is, and we did all this the other day, pi over 2 is right up here. That's also the same as 90 degrees. So it could have just said 90 degrees here. All right, so that ordered pair right there goes over 0, up 1. So now when I go through to find my 6 trig functions, sine matches up with the y value is 1. Cosine matches up with the x value is 0. Tangent's y over x, y is 0. Sorry, y is 1. 0 is my x value. You can't divide by 0, so this is undefined. I'm going to go through, I'm going to flip all these. If I flip 1 over 1, I still have 1. If I flip 0 over 1, I've got 1 over 0. Can't do that, so that's undefined. If I flip something that's undefined, then I've got 0 over 1, and that's 0. So if you kind of like pick up on this, you're going to have some 1s, you're going to have 0s and undefineds. They're always the reciprocals of each other. That happened in both of these. So just kind of, watch for that. If you get an angle that's on the x or y axis, this is what's going to happen. All right, let's try one more, then we're done. All right, so our last one here is 3 pi over 2. When we looked at a full circle is 2 pi or 4 pi over 2. So we're still within a circle here. This is pi over 2 here. This is pi, 2 over 2. Here's my 3 pi over 2. It's down at the bottom. That's also the same as 270 degrees. These always go by 90s. 90, 180, 270, 360. This ordered pair goes over 0, down 1. Might help to label your x and your y. Sine always matches up with your y. Your y is -1. Cosine matches up with your x. X is 0. Tangent is y over x. I did that again. Why I wrote that. I'm going to write x. There we go, sorry. Tangent's y over x, so y is -1, x is 0. Can't divide by 0, so that's undefined. Now we're just going to find all these reciprocals. If you flip -1 over 1, it's still just -1. If you flip 0 over 1, that becomes 1 over 0, and that's undefined. And you guys don't have to write this. You can jump right to undefined. If you flip something that's undefined, 1 over 0, you get 0 over -1, which is just 0. All right. Go ahead and give the homework a shot. Let us know if you have any questions. Bye, guys.